Hi everybody. In this session, I want to give you some practical guidance on how to get set up with your environments. So as mentioned, there are a number of different configuration options that you could choose for running Python notebooks, Jupyter notebooks. So let me just start with Visual Studio Code. So if you're brand new to Visual Studio Code, what you need to do is you need to go to the website, which is code.visualstudio.com, or just Google Visual Studio Code, and you'll need to download it from there. It should be free. You don't need to pay for anything. Obviously make sure you choose the system that you're on, whether it's Windows, Linux or Mac. It's very versatile. I don't think you even need to enter your email at this point. Potentially if you're signing into your Microsoft account or any other type of account, you will later. But that's where you can download it from. I won't go through the entire installation process because that could maybe take a bit of time. I don't remember changing any default settings, so just all the default settings that it goes with. Probably the very first time you run it, it's going to ask you to select themes. If you've got an account, sign into that. Typical sorts of setup. And then once you've done that, let me save all my changes. You'll probably be presented with a start screen that looks a little bit like this. Okay, for getting started up with Visual Studio. I'm on a sort of dark theme here. You might prefer a lighter theme, which is totally fine. But one of the advantages of Visual Studio Code is that unlike the versions of Visual Studio which are named after the years that they were published and the sort of enterprise versions of them, Visual Studio Code is the lighter weight than the heavyweight versions of Visual Studio. So you can easily add in extensions to Visual Studio Code as and when you need it. And hopefully that will become clear when you download it and install it for the first time, that it's fairly easy to get set up with. Some key things you'll need for this module obviously is the Python extension and the Jupyter extension to be able to run Python notebooks. I will get to that very soon. That's the extension tabs, this sort of module block-like icon that we have here on the left-hand side. Worth saying that if you're getting this Python notebook from Blackboard, our VLE, you'll find that in the corresponding folders, so make sure you download that, save that somewhere. I'm actually using a repository via GitHub that I set up and maintain. So however you're storing this, you might even want to prepare it for a repository, so you might want to group them together into a folder. You can either open the folder, which is what I've got set up here for the GitHub repository. If you're just literally getting started without any form of version control or Git integration, you may just want to open the file. Okay, so whichever you have set up. I'm just going to open up the folder so that I can show you a number of things. So let's start with extensions. As mentioned, you'll need to install Python. In fact, sometimes when you're opening things for the first time, it's actually going to crop up in the bottom right-hand side. So if it asks you to install Python, go with that. It should be the official Microsoft extension. It should be this. If you search for Python, it should be this. You can tell the Microsoft blue check mark there. That's what I'm using. And you probably hopefully get a prompt to install Jupyter as well. Again, just the official Microsoft extension. If for any reason you don't get prompted, you want to install those two extensions so that you can run these interactive Python notebooks. Okay, so you'll recognize a lot of this content as it forms the content of our lectures. Okay, and at the end, you've got the code cells as well and the markdown cells for the exercises. Okay, so what you want to do, again, setting up first time, you want to make sure that you've got the Python kernel. Now, if you'd installed this via VSC, it's probably going to be in your central location for your applications. It is slightly different on Anaconda. I should probably mention that as well, which is another data science and AI distribution that also allows you to run Jupyter Notebooks. Here in VSC, you're probably going to be running the Python extension you've just installed. Of course, you can select others as well. So just check that you've got access to Python and that you can write something and just check that it prints the screen. Okay, so let's just show you that right now. All right, so just press the green triangle to check that you can print stuff to screen. So as far as getting set up, that's really kind of where you want to get to for this first week, just making sure you can set up and run Python. Okay, so just check that you've got access to it via VSC. Okay, there's lots of other good stuff that you can do in Visual Studio, such as the Git integration. It manages the changes. You've got, if you've signed into your account here, you can synchronize the changes directly. You could also use GitHub to do that as well. GitHub Desktop, it will see the changes that you've made each time you press save after making some changes. It's going to recognize that. Let's refresh that. Hence, a new change has happened. And the idea really of version control is to provide a short summary comment that you can then use to synchronize your repositories. So that's something we'll probably come on to a bit later. I appreciate if you're just getting started with programming, it's probably going to be quite a lot to get to terms with. So maybe park version control and come back to that. We've got plenty of time to look at that during the module, but just showing you that's an advantage of using Visual Studio Code because it's got that integrated under this fork-like icon, nodes connected together, okay? And obviously you've got your file navigation view as well. You can look through folders and open certain files. So that's why I like Visual Studio Code. It's also got the access to the API, the documentation, not documentary. So as you can see that, you can get sort of documentation as to what's expected from certain functions, some helpful insight there as to what's required, which you don't always get access to in other environments. So speaking of other environments, I should probably show you some others that you could use. So let me show you those. Where is my, there we go. Let's talk about Anaconda. So Anaconda is a distribution specialized for data science and AI. It's a free download as well, which is good news. Don't need to pay anything for that. Just need to supply your email. So as long as you're happy to supply your email, you don't have to sign up for marketing content. You can ignore that. Okay, but again, it's portable, it's cross-platform. You can download it for any major operating system. Let me fast forward again. I don't think I changed any default settings with that installation. The one thing to be aware of is that it will install it installs a version of Python and puts it in a different folder. So just be aware of that. Oh, and in fact, one thing I can show you. Let me launch. I'm thinking ahead. Let me launch Jupyter Notebooks from here. So once you've installed it, you'll get an array of different services and different packages that you can run. Notice that VS Code is one of them. You've also got PyCharm and other IntelliJ. Sorry, not IntelliJ, JetBrains products. JetBrains makes IntelliJ. Other products within that sphere. You can get access to those as well as plenty of others. So let's launch the Jupyter Notebook from within Anaconda. And you notice it actually generates a terminal. I'm on a Mac here. So it's generating a terminal which is acting as the local host server. So this simulating the server at the local end, client and server architecture. So essentially it's a web app. It's running Jupyter in the browser as a front end and sending requests back to this, this local host here, simulating a server. Obviously it's not on a real server, it's simulating it here. But it's given us an address. It's given us a local host and a port number. It's put at 889, I think probably because I had another one open, which was at 888. So yeah, it's created a new one at 889. It's probably going to be 888 for you because you'll be just having one instance. So sorry about that. I should have closed my other one down before I did this, but it's at a port number and it's at the local host address. So what does it show you? Well, it shows you the file directory. what you want to do is you want to navigate to the same place that we were pointing Visual Studio Code to, so whether that's a folder or whether that's a certain file somewhere in your directory. Let me just now point to my GitHub folder where I've got everything set up and everything in place. So let me go to Com4008 and let's go to the first week. Let's open up that first notebook, one which you've just seen. And actually I need to open up this one rather than the other one. So let me open up this one. And again, you should recognize this. It's the slide content plus various code cells. So this is the same Jupyter notebook, but in a different view, in the Jupyter Jupyter Notebook product, rather than Visual Studio Code's extension and reading of that Jupyter Notebook. Okay, so it's a slightly different view. Runs in the browser as opposed to Visual Studio Code. But the good news, as long as you're connected to a version of Python, you can run and compile Python code and run it in the browser, which is good. I think that's a deliberate error. That isn't a problem. Isn't a user error. That's a deliberate error. So there we go. That's just showing us that we can run Python here as well. So we've got all the typical things we'd expect to see. We've got run. We can move code cells up and down. We can insert cells above and below. We can change their type from code cell to markdown. So we can do all the typical features that we would intend to do in Visual Studio Code. So I'm pretty agnostic on this, whichever one you want to run. Indeed, there's others as well. I'll show you a couple of those as well, such as Colab in a moment. There's also Anaconda code in the cloud. Kaggle have got its own Jupyter Notebooks readers. There's many different services that will run Jupyter Notebooks. Just pick a service, one that you like using, to be able to make sure you can just get Python off the ground. That's what we want to do in our initial weeks. If you're a data scientist, you're an artificial intelligence engineer, potentially you might specialize in on this type of environment. Before we move on, actually, let me just show you quickly, if you did need to connect your Visual Studio Code to Anaconda, remember I said that Visual Studio Code extension installs a version of Python separately to the one that Anaconda installs. We're going to show you that now because you'll see a different address, a different file directory for this Jupyter server. So if I wanted to connect to this local host server that's running, it's the back end for my Jupyter notebook, which Anaconda was using. If I wanted to connect to that, if I say select a Nav terminal, an existing Jupyter server, what we can do is we can actually copy in this address, which is pretty much the same as what we see here. If we copy that in, oh dear, too many tabs, sorry. Let me go to here. If we copy that in, not 88, it's 889, isn't it? Yeah, so I need to make sure I've got the right one. There it is, 889, because that's the one that's currently running. Let's copy that into VSC, connect to the Jupyter server, localhost, and notice how the IPy free is at a different address to what we saw before, which was in a different file directory. So if we connect to this one, it's Python free, and it should route through to here. Okay, so let's put this to the test. Let's type in a Python command. Classic hello world. See if it's going to connect to that. Yes, it's going to connect to that server, send the request to it, and the response back, which is the output of that, which is great. So it allows me to navigate between, here we go, here's a good contrast between Anaconda's Python installation and the local installation of Python free on Visual Studio Code, or just generally a version of Python that can be used. So it's it won't make much difference in terms of our initial weeks, but obviously Anaconda does have some data science libraries such as NumPy, Pandas, scikit-learn, matplotlib, seaborn, etc., installed as part of the distribution. So subtle differences when you start get to that. Of course, you can install and extend with these libraries. It's not a big deal, but just showing you there are some advantages to connecting to Anaconda as it's got them all installed for you. Okay, so anyway, some points there just in case they come in handy later, just to show you all the different routing configurations that you can get set up. You just need one version and one configuration that runs. That's the key thing you want to focus in on. So there we go. There's Visual Studio Code and there's Anaconda. While we're here, let me just quickly show you Google Colab. So Google Colab is a cloud, purely in the cloud. We haven't got any local hosts here. It's all done on the cloud. So we can upload our IPNYB file. Let's get it from here. Let's put that into it. Let's just drag and drop. When you go to colab.google, you probably will need a Google account, either set one up or use one that you've got set up. You can load examples or ones on your G drive or even from GitHub if you've got it connected. But maybe as we're starting out, just upload it. Not that, sorry, too many things open. Let's go here and let's close all these things down. So we can get access to stuff, too many things open, should have cleared this up earlier. Let's drag and drop this, let's upload it to the cloud, and will allow us to connect with Google's version of Python and run stuff completely in the cloud, so we don't even need anything installed natively. Let's put this to the test, press on run there. Take a minute or two just to connect through to the back end. There we go, and it's sent it back to us. Brilliant. So no need to even install Python. We can just route straight through and make use of Google servers. Potentially, there is a limit to the free version of this. There are paid versions of Colab. I think probably for basic stuff it's going to be okay. It's obviously when you start getting to the more data-intensive operations where it might start timing out and saying you've used up too much bandwidth. We're not happy with that. So yeah, but for basic stuff, that's going to be okay. So there we go. Lots of configuration options. You just need one that's going to work. That's the key principle here. One final thing, if I may, is to highlight AI. It's a new age now. It's 2024, 2025. So let me show you that an advantage of having running Colab is you've got native Gemini integration. That's Google's LLM. And it's side by side with your notebook. So that's quite powerful. You don't even have to go outside of the environment to get access to the LLM. Now, obviously, as an educator, I'm going to encourage fair use and ethical use of AI. We cannot condone entire solutions written by AI unless that has been, part of an exercise or part of an assignment rather than the entire assignment. So we can't condone that. But what we would encourage as fair use of AI is using it as a tutor. Use it as someone who can help you, as a research assistant, as someone that can remind you of things or give you insights. We don't want you to copy huge swathes of information generated by AI. Indeed, is it even correct? If it is correct, is it the most efficient way of going about solving this particular problem? So, it's not perfect. It's still work in progress. You're going to have to employ your critical thinking here. Don't leave your brain at the door. You've got to be able to interpret and discern whether what AI is producing is helpful to you. But it can act as an assistant. It can act as a good knowledge repository. Let's find some examples. You can ask it to remind you about things. C format specifiers. So let's, for example, because there's a lot of information there, if I didn't have this to hand, if I was further down or working on a different notebook and I'd forgotten what the C format specifiers were, I could ask it, can you remind me of the C format specifiers? There we go, and it's going to give me a list, and I could say, oh, well, okay, integer is useful, floating point, if I want to output, that's useful, string, S for string. I can then take that and put that into the code that we're doing here. Okay, so just give one more example. Let's think of something on the fly here. Oh, potentially something I forgot. How many Python types are there? Or what's the Python type for something? You know, it can give you lots of good knowledge points. I mean, it's good at writing code as well, but obviously we don't want to encourage you to write huge swathes of code. We certainly wouldn't allow you to submit your assignments generated by AI. Another good use of AI outside of code would be to generate things that are peripheral to assignments. So things like covering art. I used AI, I should disclose this, that I used AI to generate our logo and our course banner. Once I get signed in here again. So I'm happy to disclose that this course banner was generated by AI. You know, it would have taken me hours to have produced that myself. I'm not a graphic artist, so it could produce that as a prompt. That's good. That's not worth any marks. So that's a good use of AI. I think for this context, I would encourage you stuff that isn't code, stuff that isn't related, stuff you're not getting marked on, but would help the presentation of your assignments, of your work, of helping you to reword things or to you know, create stuff that's you know, not being marked. That's a good use of AI. Okay, so that's quite powerful. That's quite a new way of working that we're all having to get used to. So I hope that makes sense. I hope that's a fair and equitable use of AI. Use it as an assistant. Use it as someone to help prompt you, help remind you of things. The occasional use of providing a code snippet, you know, we'd be happy with that, especially for these formative exercises. We don't want you suffering in silence. If you really get stuck, you can ask it to help you work this out, but obviously make sure that you're not over-relying on it. Don't try and pass it off as your own. You know, be honest. If you've used AI, that's probably the best policy. We come back to the basics, don't we? Honesty is the best policy. I wasn't sure how to solve this problem, therefore I asked AI. Okay, here's what AI came up with. And obviously, if you're going to use it, learn from it. Don't just depend on it. Don't use it without learning from it. Make sure as you're getting stuff from AI, in fact, it's even got it in here, hasn't it? It's even put the prompt in here. Generate AI, it's got options to do. So there's a brave new world now. There's a brave new world. So hope that's fair. Any questions, get back to me on that. But anyway, I hope we've given you a number of different options that you can use to get set up with. I'd probably encourage Visual Studio Code to get started with, but in case you have any issues, hopefully here are some alternatives such as Anaconda and Google Colab, which of course has that native Gemini integration. So there we go. Hope that's enough to get started with. Hope that helps you get set up. So happy coding, good luck with that, and I look forward to seeing what you've come up with for these first exercises. So I'll see you in the next session.